Okay, we're going to start with the small signal model of this opamp. First of all, replace Q1, Q2, Q3, and Q4 with their small signal equivalent circuits. Do the same thing for number 5, and we're going to actually leave out number 6 in R4, and this is going to be our output node. I'm going to start with 3 and 4 on the top because it's in the upper corner. Alrighty, so we have a GM. This will be GM3, V3, and for now we're going to ignore RO. This is RPi3. RO would be right here in parallel with this GM3. Base and collector are tied together. This is 0. We also have a RPi4 GM. V4 is right there. Like that. Alright, back over to the left side. These together. That. Number 1. Back to number 1. Way down here. GM1, B1, RPi1. And this voltage is actually minus VD over 2. That node. The emitters, remember that's node 3, and we're going to call that virtual ground. Input and output are going up and down. They're differential, equal and opposite. RPi2, this is VD over 2 at that node. Here is our GM2, V2. Okay, these two are tied together, and we come over to PNP transistor, RPi5. A transconductor. That's 0, small signal. That's R3 is 10K. Tied to 0. Output node right there. Okay. I don't know that we really need to redraw this. If we could, we would take this part, flip it down, put it in parallel. This would get flipped over. Maybe not. Alright, nodes that we have here to match up with the circuit. That's node number 1. This is node number 2. Oops. 1, 2. Yeah. Node number 2. 1, 2, 4 and out are the same thing. And we're good. Alright, really, I want to match this up and find the short circuit current. I'm going to take and compute this current. IX, well, that's I4 and I2. I2 is really easy to find. IX is just KCL. I4 is GM4V4. V4 depends on what this is and depends on that, so I'm going to call this I1 and start working on I1. Alright, so I1, GM1 times, well, V1 is the same thing as minus Vd over 2. Alright. Now I1, I'm going to do KCL on the top side. 3 currents, this one, Ohm's law, which is V4 over R pi 3. Remember, this one is V3. This is a current mirror. I'm going to use, let's see, my notes say R4 or V4, 3 currents here. So I'm going to say also I1, factor out V4 is GM3 plus V4 over R pi 3. V4 is factored out, 1 over R pi 3 and 1 over R pi 4. Good with that. I'm going to go off to the side for a little bit. And look at this. Well, GM3 is IC3 over VT. Collector current of transistor number 3. R pi 3 and R pi 4 are about the same. They're going to be the same value. They're the same type of transistor, and their collector currents are about the same because of the current mirror action. And I'll call that beta VT over IC3 because IC3 and IC4 are the same. Ooh, let's see, plug this back in, plug. This is V4, and that is IC3 over VT plus, well, this is 1 over beta VT IC3 over IC3. IC3 comes up on the top over beta VT. We're going to have 2 of these, so we have 2 IC3 over beta VT. If we just take this out, we get V4 IC3 over VT. Remember, that is just GM3. And we're left with 1 plus 2 over beta, which is beta plus 2 over beta. A little algebra in our head. Alright, no problem. I4 or I1. Well, that's V4. We can solve for V4. This is I1. Let's go back up to here. I4 is just GM4 V4. Plug that in. Alright, so I4 is GM4 times V4, which is GM4 times, solve this for V4, we get, what is it, GM3? Too much. I1 over GM3 and beta over beta plus 2. It flips around. 1, 2, 3, 4. Great. Alright, what's I1? Well, I1 is GM1 minus VD over 2. And I get I4 is so it is GM4 over GM3 times beta over beta plus 2 times GM1 times minus VD over 2. Good. I'm going to do another aside here. Collector current of number 1, collector current of number 3 and number 4 are the same, so the GMs are the same. GM1 is the same as the GM on the other ones. We'll assume the temperatures are the same. All of the collector currents of these 4 transistors are the same. GMs are all the same. Because of this, those go away. And I'm going to write I4 is beta over beta plus 2 GM and then minus VD over 2. Okay, Great.